Hello guys, welcome back to Math Zone African Motives. We are still on our mathematics N6, and this is November 2023 exam, question number 2 that we are going to work on and see how we're supposed to attempt this typical question. We are asked to determine the integral of y with respect to x of these integrals that we are given here. All right, so 2.1, the integral of y is given as 1 over 8 minus 2x minus x squared with respect to x. So that is what we are given in this case, and you're asked to determine the integral of this with respect to x. So this definitely here we are supposed to think of what completing of the square method according to our syllabus. That is the only thing that we can have here. So we are going to complete the square. So by completing of the square, in this case. All right. So we have this quadratic expression that we can write in the form of ax squared plus bx plus c. Remember our format of the quadratic expression. So this is going to be minus x squared minus 2x plus 8 is equal to, all right. So what are we going to have? We have got two ways. It's either we're going to use the formula or we're going to use the traditional method where we can factor out the negative so that the coefficient of x squared becomes a positive. So this will be x squared. Factor out a negative here is going to be a positive 2x. Factor out a negative, this will be a negative 8. Plus and minus, it gives us a minus. So what, remember our traditional method that you are supposed to find or determine half the coefficient of x. This is the one that you're going to need to complete the square with. So we need half of the coefficient of x, which is the coefficient of x is 2, then we square it. So half of 2, that's a 1. Then we square this, which is 1 squared is just a 1. So this is the same as we're going to have minus into x squared plus 2x. We add the square, and at the same time, we are supposed to subtract that same square that we added here. So we are supposed to subtract the square, all right? So that we'll be able to complete, in this case, to factorize this expression, the quadratic, because here we have formed a quadratic expression, if you take a closer look here, which is a perfect square. So this quadratic expression that we see that I'm indicating here is a perfect square. So in order for you to factorize that, you're just going to focus on the first term, x, and the last term, which are being raised to the exponent of 2. So that this is going to give us x, here it's a 1. So this is x plus 1 squared. So that's how you factorize. Take the first term and the last term. All right, then the rest of this part, you just have to simplify. That's minus 1, minus 9, minus 1, which minus 8, minus 1, which is going to be minus 9. Okay, so it can affect by the negative times this bracket is going to be minus into the bracket of x plus 1 squared minus, and minus 9 is going to be a positive 9. All right, so we can just write starting with the positive, which is 9. So that will be 9 minus the bracket of x plus 1 squared, like this. All right, so this we have completed our square, but here we were applying, or we were using the traditional method where we have to make this square root of x squared to be positive, then we complete the square. But we could have used the formula in this case. Remember from our quadratic formula, it says that we can complete the square in this case if we are given any sort of a quadratic formula. Let's say we are given in the form of ax squared. Let me write it here, x squared as our quadratic formula plus bx plus c. It can be given as 4a. So this is 4ac minus b squared over 4a plus a into the bracket of, that will be x. In this case, it's going to be x here. Going to have x plus b over 2a squared. So this is the formula that you can use to complete the square direct. Instead of having like this part, we can complete our square using this formula. So this is going to be what? 4ac. So from our quadratic here, this is our quadratic here that we had minus x squared minus 2x, remember? This was minus, all right, minus x squared. It was minus x squared minus 2x plus 8. Before you change this to factorization, this and that, we are using as it was before. All right, so this was our quadratic. So from this quadratic expression, the coefficient of x squared there, which is minus 1, that's our a. So it's going to be 4 times minus 1, which is 4a times c, the constant, which is 8, minus b squared. B is the coefficient of x. So this is going to be minus 2 squared. So it's going to be minus 2 squared over 4 times a. Our a is the coefficient of x. And what is the coefficient of x? That is, the coefficient of x squared, which is minus 1. All right. Plus our a, remember our a still minus 1 into the bracket of x plus b over 2a, b, which is minus 2. So that's minus 2 over 2a, which is 2 times the coefficient of x squared, which is minus 1. So that's it. So if you do this, you obtain the direct answer as the one that you have obtained here using the traditional method here. All right, so you obtain the same answer. So this, if we simplify this properly on our calculator, it is going to give us a 9 plus and minus. That will be a minus into, that will be x minus and minus. This one cancels, 2 and 2 cancels. It's going to be x plus 1 squared. All right, so let us see if this is the same, and this is exactly the same as this part that we had, 9 minus this bracket of x plus 1 squared. So this is what we had. So whether you are using the traditional method, you're using the formula, whatever that you're going to use, you are supposed to obtain the same answer after completing of the square. So this is what you do. You are going to take the answer that you got after completing of the square. Now we substitute to the integral, because here we are supposed to integrate this. This is our question. We are supposed to have our integral of this part here. So we are going to take from the normal function, this one that we completed, the square here. This is what we got. After completing of the square, this is what we got. 9 minus the bracket of x plus 1. So this is what we're going to substitute. So this is going to be the integral of 1 over 9 minus the bracket of x plus 1 squared as it is. This is what we got from our completing of the square. So this is what completing of the square is all about. It helps us to find an expression that can be integrated, because this one cannot be integrated as it is. So by having this now, we have something that can be integrated. And sometimes you might even wonder, even by now, you might be wondering, but how is it that this one, the function that we have now, it can be integrated? How is that possible? All right, I want you to see something from the formulas. I always say about this, whenever you're working with the completing of the square, you are going to use these integrals to integrate whatever that you have from here. We're going to have these integrals up to the last part here of these integrals, up to the last one here. There's only one integral that we are supposed to use, and that integral is supposed to match whatever that we are given in terms of these answers that we have on the right side. All right. So there we are given, we are now at a stage like this. I'm just going to write aside so that we can check which one is the best. It was the integral of 1 over 9 minus the bracket of x plus 1 squared. It was x plus 1 squared like this with respect to x. So which one is going to be the best part to use of these integrals that we are given? Which one is going to be the best? All right. The first one we are given the square root in this case. Here there's a square root. So this one is totally out. We do not have a square root. So this one is not going to work. All right. Let's move on to the second one. The second one, we do not have a square root here, but there's a plus. And there's no way we can factor out this negative and both terms will be positive. One, either way, one is going to be a positive. One is going to be positive, one negative. So this one is totally out. Here we've got the square root of this is totally out. All right, here we're given the x over a squared minus b squared x squared. So take note, this here is the same as this one, a squared, which is the same as 9. Then we've got this part of b squared x squared, which is the same as this part. So this is the best formula for us to use. All right, so we're going to use this formula. All right, we've checked this one. There's a square root. We cannot use this. Here, there's also a square root. We cannot use this. So this was going to be the best formula for us to use. So you're going to take this formula, you use it to integrate. So I'm just going to rewrite this. Let us see. So remember, our formula there is stating that if we are given the integral with respect to x, and those integrals are with respect to x. So this integral is with respect to x, and we are given on that formula as a squared minus b squared. So take note, the way it is given as a squared minus b squared x squared like this. And I said, this is going to give us, 1 over 2ab, 1 over 2ab, the ln of a plus bx. So I'm just going to explain it this way, a plus bx over a minus bx plus a c. Okay, this was our formula. So let us interpret our formula. The integral of this, is it exactly? Yes, this is 3 squared from a squared. All right, then b squared, we do not have a number, so you're just going to write as 1 squared. Then x squared is represented by this bracket of what? Of x plus 1. So this is exactly the same format. So this is the same way as writing as dx over 3 squared minus 1 squared into the bracket of x plus 1 squared. Why are we just writing? We're just writing this in a way that we can properly see this is our a, like a squared. This is our b, like b squared. This is our x. The whole of this part represents your x. So you've got your a, your b, and your x. So you're just going to substitute into the formula. So this is 1 over 2ab over 2 times a. Remember our a, we said is 3. Then our b is a 1. We do not have that number, so it's just 1 squared, which is 1. Okay, the ln of a plus bx, our a we said is 3, so this is going to be 3 plus bx. B is 1 times x, our x is x plus 1, so you substitute as it is x plus 1 over a minus bx, so it's 3 minus 1 into x plus 1 is just a repetition of this part on top, but only that now we've got what? A negative, plus the constant of what? Of integration. So we have the format first, then we use the format now to simplify. So here, that is what we are going to have at the end. So you can just simplify. That will be 1 over 2 times 3 times 1, which is 6. The ln of, here you can just leave it like that, 3 plus the bracket of x plus 1, the one that we had here, over 3 minus the bracket of x plus 1 like this, plus the constant of integration. So we can leave it at this stage like this, all right? That is, you're going to have full marks. Or you can expand your brackets here. We can expand our brackets. So this will be 1 over 6. The ln of, if we expand this by 1, it's going to be x plus 1. So it's going to be 3 plus x plus 1, which is 3 plus 1. That will be 4 plus x over, in the denominator, this is 3. We expand by minus. Minus times x is going to be minus x. Minus times 1 is going to be minus 1. So 3 minus 1, which is 2, minus x like that, plus the constant of integration. So we could have even expanded the brackets and write your answer in that way. It's still one and the same thing, all right? That is how we're supposed to have this. So as long you are working with a part of completing the square, you have to complete the square first. Then you check for the formula that is appropriate. There's only one formula on those formulas that I listed before that is going to be appropriate, okay? That is the idea of this question. 2.2, all right, question 2.2, again, it is integrate of y with respect to x. And this time, this is, all right, 2.2, the integral of e to the exponent of minus x, the cosine of x with respect to x. So whenever you are working e and a trig, all right, you are working an exponential and a trig function, you are supposed to apply by parts. We talked about this, all right? You are supposed to apply by parts, and you are supposed to apply that by parts 2 times. You're going to see that you applied by parts 2 times. Okay, how so? Okay, remember that the by parts is used on a product of 2. These 2 terms are multiplying. So we know that the formula is that f of x by g prime x dx is equal to f of x by gx minus the integral of f prime x gx. You are also given this formula in your formula sheet. So we have this. So our f of x, choosing our f of x, in this case, I'm going to choose it to be an exponential. As for an exponential and a trig, you can choose any to be your f of x, any. All right. So as for me, I'm just going to choose my f of x to be e to the exponent of minus x so that we can have the first derivative. As we can see, we need the first derivative from our formula. So what is the first derivative of this? Drop the exponent here. So this will be minus 1, which is minus e to the exponent of minus x. So that is what we have from what? From the first derivative. All right. From f of x, we find the first derivative. Then from the cos x dx that is remaining, that means that's our g prime x dx. So we're going to have our g prime x dx as the remaining part, which is the cosine of x dx. So what do we obtain here? Gx. From integrating of both sides, we are going to obtain gx on the left-hand side, which is equal to the integral of cos. The integral of a cos aside, remember, we differentiated a sign and we got a positive cos. So if you integrate a cos, it will be still a positive sign. So this will give us sine x. There's no need for us to write the cost of integration since we are still integrating, yet to integrate again. So that is what you're going to have. So it means the whole integral of this part that we had, which is the integral of e to the exponent of minus x, the cosine of x is equal to f of x by gx. So that's f of x e to the exponent of minus x by gx. We got sine of x. So this will be sine of x minus the integral of the first derivative, which is minus e to the exponent of minus x by gx dx. Our gx, remember, that's the sine of x. So you're going to have this. Okay. Now, this is what you're supposed to do. This is a substitution as usual of our by parts. All right, we get this to the formula. This is what we're supposed to do if we are to check. We're supposed to simplify on the right-hand side. This was going to e to the give us e to the exponent of minus x. All right, sorry for that. Minus x like this, the sine of x. All right, negative. If we take this negative and negative, it's going to be a positive. So that will be positive. The integral of e to the exponent of minus x, the sine of x with respect to x. So I want you to see something here. In a normal consideration, in a normal person, you are supposed to integrate this. This is what you're supposed to do. We are supposed to integrate this. But this one now, if we check, it's a product again of two terms, just like what we had here previously on our integral of this with respect to x. It was a product of two terms. It was e to the exponent of minus x cos of x. This is what we have, but now we've got sine of x. So meaning to say on this part, for us to integrate this, we are going to apply by parts again. We are going to use by parts because it's a product of two terms. So we let us have our integral. So I'm just going to integrate this part. I'm taking this part alone, this one aside, e to the exponent of minus x sine of x. So we're going to take this. Let us just integrate this one aside. We just want the answer there. So the integral of e to the exponent of minus x, the sine of x with respect to x is going to give us, right? Still, it's a product. So we're going to use our by parts. So f of x, you choose. So since we used exponential as our f of x in the first part, we're going to continue maintaining that. So our f of x is equal to e to the exponent of minus x. So in fact, it's a repetition, this one, because we had the same f of x previous. That's what we choose. So it's going to be the same answer for the first derivative. All right, so here there was no need for us to rewrite. So it's going to be minus e to the exponent of minus x. Remember that, what we did. All right, then the remaining part is going to be your g prime x dx. So we've got a g prime x dx, which is the part that is remaining for sine of x dx. So that means we have to integrate both sides to obtain our gx. So our gx, what is the integral of a sine? Remember, if you differentiate a cos, it gives you negative sine. So if you integrate a sine, it will be a negative cos, the reverse of our cos. So that will be a negative cos in that case. So this is what we are supposed to have from your by parts. The by parts formula is not going to change. That the integral of this is supposed to be equal to f of x by gx minus the integral of f prime x. This time it was f prime x. All right, let me just try it this way. It was f prime x gx, right? So the formula is not going to change. Whether here we are working with another by parts, it's not going to change. So meaning to say, from this integral that we are having of this sign, this one, what are we going to have? We are going to have f of x, which is e to the exponent of minus x by gx, which is minus cos x. So this is minus cos of x like this, minus, we move on. Here we're going to have the integral of f prime x, which is from we got minus e to the exponent of minus x times gx, which is we got here minus cos of x like this with respect to x. So now this is exactly what I want you to see. All right, you were supposed to simply remember you're integrating. What are you integrating here? We are integrating e to the exponent of minus x. Then after simplifying, now you multiply this and this, you're going to have minus e to the exponent of minus x, the cosine of x. All right, here, negative cancels, that will be a positive. So meaning to say this negative out is not affected. It's going to remain as it is. So it's going to be e to the exponent of minus x cos of x like this with respect to x. All right. This is the integral that we are obtaining of e to the exponent of minus x sine x dx here from this one. Meaning to say, by parts, this is where we are. And we have this bracket. We are supposed to integrate again because this one is by parts again. But now if we take a closer look, it's no longer just a normal function, this one, e to the exponent of minus x cosine of x, this one. If we take a closer look, it is the one that we had originally from our question here. That was our original question in actual place here, e to the exponent of minus x cos of x. So we are not going to repeat again, because if we repeat our by parts, we are going to have the same answer as this one. We repeat again, we come to this stage, this one, we repeat for sine, we have this, so we are not, so it is going to be a continuous repetition, integrating again. So what do? You combine your solutions, because remember we said all this, it was because we wanted to integrate this here, and we got the answer here. So we are going to combine everything from the integral that we had, of course, in the actual question here. Remember, that is our integral that we have at this stage. So we are saying the integral of e to the exponent of minus x cos of x dx is equal to, we already simplified this part. We got e to the exponent of minus x sine of x like this, plus the integral of e to the exponent of minus x sine x dx, which is the one that I said we are supposed to apply by parts again. And when we did that application of by parts, this was our solution here. All right, we got this answer here. This was our solution, the whole of this part. So we are going to substitute the whole of this part as it is here. So we're going to add. So addition does not affect plus and a minus. It remains as a minus. So this will be a minus because there is what? A plus. So plus and a minus is going to be a minus. So this will be minus e to the exponent of minus x like this, the cosine of x. All right, then plus and a minus here still remains as a minus. So it will be minus the integral of e to the exponent of minus x cos of x dx. Remember, this is the one that I said we are supposed to use again by parts, but instead of you using by parts, you are going to just retake that solution of your by parts, the one that we had from this one. Just take that solution. All right. So I'm just going to focus on this one. We are done with it. All right. I'm just going to remove so that we do not have, like, we've got a lot of things. But if you want, you can reverse actually the video so that you can properly see. Now that we have combined that integral that we had, this one for e to the exponent of minus x sine x, which is the one that we combined here, plus, and we've got this integral here, this part that we have here. So what are we going to do? we can see that we have the same integral that we have on this side. We have the same integral. So we're going to combine these integrals together. So we take this negative to the other side, so it's going to be a plus. So these are the same. It's like we have both x here, and there's x plus x. There's x plus x. What do you get? X plus x is going to be 2x. So it is the same thing. If we take this integral, this side, it adds because it is a negative there. So it is going to add on this side. So it is going to be 1 plus 1, which is 2, the integral of e to the exponent of minus x cosine of x dx, which is equal to e to the exponent of minus x, the sine of x, minus e to the exponent of minus x, the cosine of x on this side. So this is what we have. We just made this one what we want to be. The other side, it adds because these are like terms. And this is our question. We are supposed to integrate this. So what can we do? What is affecting is 2. So divide by 2 both sides. So we're just going to divide by 2 both sides so that we remain with the actual question that we had, which is the integral of e to the exponent of minus x cos of x dx is going to be equal to this whole solution that we have on this side. So this, you can just write it as 1 over 2. It is supposed to affect everything. So you can just even open a bracket like this. E to the exponent of minus x, the sine of x, minus e to the exponent of minus x, the cosine of x plus the constant of integration. So like I said, it affects everything. So you can even factor out e to the exponent of minus x1. You can expand it inside of the bracket if you want. That is how you can find the integral of this. So that was our question. That was our question, all right? This is how you play around with this type of a question. You have to integrate 2 times. Here we apply, but when you integrate, you have the same integral as what you had on your question. So you combine them to be a single integral. That's you make it the subject of the formula. All right. Then we've got a tan to the exponent of 5. All right. This tan, remember tan, you have to expand until the last stage of your integral. That's how you deal with a tan. The way you expand a tan and a cos is different. So tan, you expand it up to the last stage. And also on your expansion, you must bear in mind that you are supposed to have or to apply the identity of tan squared. Remember that tan squared x plus 1 is equal to sec squared. So if we make this the subject, it is going to be tan squared 3x. Tan squared 3x is equal to sec squared 3x minus 1. Remember, if it is a tan squared plus 1 is sec squared. So we want to make tan the subject. So you're supposed to expand this in terms of tan squared. So this is going to be the integral of tan squared 3x. To obtain to the exponent of 5, you multiply by tan to the exponent of 3x like this. So that will be 2 plus 3, which gives us a 5. But if it was a sine, you expand in terms of sine squared 3x like this to the exponent of 2 times another sine 3x like this. So that 2 times 2, that's a 4 plus this one, you get a 5. But for tan, you don't expand like tan, then you square that tan. For tan, it's impossible. You use it this way. You expand that way for tan and for cot, all right? So substituting here tan squared, which is equivalent to sec squared minus 1. So this will be sec squared 3x minus 1 into tan cubed 3x dx. So what we are simply going to do is to expand so that we separate. Remember, I said this one you expand up to the last term. So you're going to take the tan cubed inside of the bracket. It expands these 2 terms. So it's we are going to have the integral of sec squared 3x times tan, which is tan cubed 3x with respect to x. All right, you multiply this negative 1 to tan, so it's going to be minus the integral of tan cubed 3x with respect to x. So if you are to consider that it was an exponent of 5 for tan, and now we have got a sec and a tan here. So on this one, you leave it like that. You are going to use substitution method to integrate this one. But if we check here, there is another tan again, just like this one that we had before of tan to the exponent of 5. So we are supposed to expand this one again in terms of tan squared. So that's why I said for tan, you expand, 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 and expand. So you expand in terms of tan squared. We said this is going to be tan squared 3x. But in order for us to have tan to the exponent of 3, what are we supposed to do? We multiply by tan what? We multiply by tan 3x, so that this will give us tan to the exponent of 3. So this is what we have. Remember, always where there's a tan squared, what are we supposed to do? This one, okay, let us just rewrite this. Sec squared 3x, tan cubed 3x dx like this. Minus, remember what I was saying? Wherever there is a tan squared like this, wherever we have this, we substitute with what? With a sec squared minus 1. So this was supposed to be into sec squared 3x, sec squared 3x, because there's a 3x there, minus 1 times the tan, this one that is outside of what? Of the bracket of this, which is multiplying the tan squared. So you're going to multiply by tan 3x, which is outside with respect to x. So if we check, this expansion here is the same as the expansion that we had on this bracket here. There was a condition like that where I said we have to expand everything by tan, but separating your integrals. So this is what also you're going to do. You are going to separate your integrals. So meaning to say we're going to have the integral of sec squared 3x tan cubed 3x with respect to x like this. So we separate, but noting that there's a negative here. So it's going to be negative. It affects first. So it's negative the integral of sec squared 3x. We multiply by tan because we're expanding the bracket. So it is going to be tan 3x dx. All right. You move on to this minus 1, but first there's a negative out. So it's negative times this negative. It gives us a positive. So it's the integral of 1 times tan, which is tan. So this will be tan 3x with respect to x. So as you can see, now we've got that scenario, a sec and a tan here, a sec and another tan. But on this one, we do not have a sec and a tan. So are we supposed to expand? This time, no. Why? We are now in simplest form. We can integrate tan. It is different from tan cubed. We have to expand again using the same identity, because this one we can't integrate. It is the same as this one, tan to the exponent of 5. And even in a certain condition, they can even ask you to integrate tan to the exponent of 3. They can even ask you to integrate this. So you just apply this identity. Then at that stage, you expand everything. So using substitution method on these first two, we are going to see that these first two, we can use substitution for tan and tan, so that we eliminate sec squared. So you're going to let our u be equal to tan 3x. Remember, the derivative of u with respect to x for a tan will be 3. Tan changes to sec squared. So that will be sec squared 3x. So you can make dx, this is the same as over 1. So you're going to make dx the subject, cross multiply. So it is going to be du over 3 sec squared 3x, like that. All right. So that means on your integration here, on your substitution for the first two, these ones, you were going to substitute dx in place of dx here. So if you check properly, if you substitute dx, which is du over 3 sec squared 3x and sec squared 3x, we're going to cancel, meaning to say we're going to be left with 1 over 3 du. So you're going to take this 1 over 3 out of the integral on this one. So it's going to be 1 over 3, the integral of, remember, sec is cancelled. This sec squared is cancelled what? With this sec squared. So we're just left with the tan cubed. And tan represents what? U. So that will be u to the exponent of 3 with respect to u. All right, minus, we do the same thing, the 1 over 3. We take it out of the integral, so it's going to be 1 over 3. The integral of sec squared will cancel with this, just like the previous case, because these two, they are using substitution. These two, they are using substitution. So meaning to say this will cancel with this one, remain with what? With 1 over 3. Tan is represented by what? By u. So you're going to integrate this with respect to u. All right, plus On this side, we've got a tan, and like I said, we can integrate a tan. There's no need for us to apply any substitution. The substitution is only for this part, all right? So now we can integrate our terms each separate, okay? So this one is gonna be 1/3. Integrate u to the exponent of 3 with respect to u, that will be u. We add 1, yes, so remember we have to add 1, that will be 4, over the new exponent, which is 4, minus a third. The integral of u is same as 1. So if we add a 1, so that will be u to the exponent of 2 over 2 like this. All right. Plus we do the same thing for the tan. We integrate, but for tan we have a straightforward integral that affects a tan. All right. We have got a straightforward integral that affects a tan. So I'm just gonna write it down, but I think I have got this on your formula sheet. So I'm just gonna explain from the formula sheet also, so that you also understand your formula sheet. So if you check on your formula sheet here under integrals, these are this is a function of x, these are derivatives, these are integrals. So we want to focus under integrals. We are focusing under these integrals here. So we need where there's a tan. So if you check down here, there's a tan here, down here, this one, a tan. So it states that the integral of tan ax is 1/a ln sec. So that one, it was the integral of tan, remember, is tan 3x. So if it is tan 3x, what does it mean if it is tan 3x? It means where there is x here, we are just going to where there is a in this case, this one. That is where we're going to affect. So this one is going to be 1/a, which is 1/3, ln sec ax, which is ln sec what? 3x. We're just going to put a 3 where there's what? Where there's a. So that is how you apply your formula. There's nothing there that is special for that tan. You're supposed to know your formula only. You substitute there. All right, so that is it for this tan. We're going to substitute. So this will be, as we saw, we're going to get 1/3. So it gave us 1/3. The ln of sec, so it was the ln of sec 3x. All right, like this, plus the constant of integration. So that's it, we are done. So instead, we can just substitute now, because remember here, we were dealing with the u, which is represented by tan. So wherever we see a u, we're going to substitute tan 3x. All right, so that will be 1 numerator times numerator is supposed to be u to the exponent of 4, but u is tan. So it's tan to the exponent of 4 of 3x like this, over 3 times a 4, which is a 12. All right, minus 1 times u squared is u squared, but remember u is a tan. So it's going to be tan squared 3x over the denominator to the denominator 3 times 2, which is a 6. Okay, plus 1/3. This one you're just rewriting as it is. So this will be 1/3 the ln of sec 3x. So this is ln sec 3x like this. All right, so that is it, just like that, plus the constant of integration. All right, so we've considered everything as part of our solution. Everything is there. Also, do not forget the constant of what? In the constant of integration at end. So that's how you integrate what? A tan. You have to play around. You expand a tan until the last stage, up to here, where you can be able to integrate everything. Once you are yet to reach that, expand and expand, as long there is a possibility for you to split the tan, whether it's a tan cubed, as long it can be splitted in terms of tan squared times another tan, we have to split this. We have to split into this so that we can substitute with the equivalent identity. So meaning to say, for a tan to the exponent of 5, this one, it is supposed to be tan squared x by tan. It was supposed to be tan squared x like this times tan x. This was supposed to be your normal approach, whereby this here is going to give us 1. That was sec squared. All right. So this one is going to give us sec squared minus 1. All right. But whatever that you have, because here, if you write another sec squared, it will be like you are multiplying. That's why we are avoiding this. So now to have this expansion in fuller terms, that's why I said combine this, make it to be a single tan, so that we just have this as tan squared x times tan to the exponent of 3x, right? If it is 3x, we use 3x. If it is 4x, we use 4x. If it is 5x, we use 5x. But the idea there is supposed to be this nature, where this one can be substituted with the equivalent identity. But I said for cos and for sine, don't expect to expand it this way. The expansion is different. You expand in the form of sine squared x. Let's say it was to the exponent of 5 and it is a sine. Then you square it. This gives us sine to the exponent of 4. Then we have to multiply by another sine so that it gives us to the exponent of 5. The expansion of a sine and the cos are the same, but they are different to that of a cot and a tan. So tan and the cot, they move together, sine and cos together again. All right, let us check the sine on 2.4. Integrate, that's a sine and a cos there. The integral of cos to the exponent of 5 pi x, then sine to the exponent of 3 pi x like this with respect to x. This is what you're given to integrate. All right, whenever we are given an integral, it can be of this sine, starting with sine, or you can start with the cos, as long as there's a sine and a cos. All right, this is what you check. The first thing you're supposed to check are the exponents, all of the exponents odd. Yes, we've got an odd exponent and an odd exponent here. So on a condition like that, you split the smaller one. All right, you split the one with smaller exponent. Split the one with the smaller exponent. The smaller exponent or the smaller power. All right, that is the one that you split. And also, if you were given one being odd and another one even, you split the odd one. So here they both are odd, so you split the smaller one. How do you split it? The smaller one is in terms of sign. We are supposed to use this identity, whether it's for cos or for sine, we use this identity, which is the same. Remember that sine squared ax plus cos squared bx ax, again, as long as these two are the same, should give us what? Should give us a 1. So since we are focusing with the one that has got the smaller power, and the one with the smaller power is the one for sine. So we are supposed to split a sine. So we are supposed to think of a sine. Thinking of a sine, that will be something like this. 1 minus cos squared ax. So when I'm saying you're supposed to split, you're supposed to split thinking in mind of having a sine squared x. A sine squared, but this sine squared, so that it can be replaced with the equivalent identity there. So how can we make a sine squared here? Is it possible? All right, this is possible, yes. That will be cos to the exponent of 5 pi x like this, and that will be sine squared pi x times, because we can't raise to the exponent of 2. If we raise to the exponent of, it will be a 4. So to get the exponent of 3, we just have to multiply. So this one, we have no option. We just have to multiply by sine pi x, so that 2 plus 1 gives us the exponent of 3. By having this, we have the sine squared. This is the one that we wanted to see here, and this is exactly what we see here, the sine squared. So what are we going to do? We are going to substitute in place of that sine squared with the equivalent identity. All right? So this will be cos to the exponent of 5 pi x into the equivalent for sine squared, and sine squared is what? It's 1 minus cos squared. This is 1 minus cos squared pi x. Since this is in terms of pi, so it's going to be pi x. Then we have a sine pi x, which is outside here. Sine pi x is going to remain as it is with respect to x. So we have expanded, all right, with the equivalent identity. So what do? You have to expand now, but by expanding, we have to take note that this here, the cos that is out of the bracket, and this sine out of the bracket with dx, both are expanding our bracket. Both are expanding our bracket. So what does it mean? It means that I'm going to have the integral of a cos here times this side, a cos and a sine together. So it's going to be cos to the exponent of 5 pi x, and a sine pi x in this case, like this dx, because we are multiplying to what? To 1. The first one is a 1. All right. The second one, there's a minus. We're going to multiply, so it's going to be minus the integral. So if we check, if this cos here multiplies with this cos, it's cos to the exponent of a 5 here, and this is cos to the exponent of 2. So what happens? You add the exponent, so it's going to be cos to the exponent of 7 pi x. Then the sine also is multiplying the cos. Remember, I said these two are out of the bracket, so they both expand at once inside of the bracket. So sine also is expanding. So we also have the sine of what? Of pi x with respect to x. That's it. We have expanded. At that stage, guys, we are done. You are done. What am I trying to say? What am I trying to say? I mean, your integrals now can be properly done, because here we just have to apply our substitution method. We can see that the sine here and the sine here, you have got the same exponent and is the lesser exponent. So we can think of eliminating that side. So that means we have to let u to be equal to cos, so that we can eliminate a side. So it's going to be cos pi x. Find the derivative of u with respect to x. Remember, cos changes to a negative sign, but we have to multiply by the coefficient of x. So it's going to be minus pi sine pi x, like this. All right, let us make dx the subject. So if we make dx the subject, this is the same as it's over 1. Cross multiply this and that, you're going to have du over minus pi sine pi x. This is what you're going to obtain at the end if you make dx the subject. All right, so it means you were supposed to substitute, just like the previous case, you are supposed to take your dx here and substitute. So if you check properly, by substituting, the sine pi x and the sine pi x will cancel, and that is what we wanted to cancel in actual place. So meaning to say, you'll be left with this minus 1 over pi, this one. So where it's a constant, so where do you take it? Out of the integral. Minus 1 over pi, out of the integral, we integrate cos. Remember, cos pi x, it's u, so it's going to be u to the exponent of 5. The sine and the sine is cancelled. So we are left with what? With the u. So it's going to be with respect to u. The same thing on this other part. We do the same thing. There's a minus out of the integral. So this minus and this minus 1 over pi cancels. Minus, minus, it becomes a, because we are supposed to take minus 1 over pi out of the integral, just like this. So if we take it out of the integral, what happens? If the negative, there's a negative there, so it becomes a positive. So that will be positive 1 over pi. But there is an integral there of cos, which is cos is represented by what? By u. So that's u to the exponent of a 7. The sine and the sine, just like the previous one, sine and sine here cancels. So meaning to say, we are going to integrate this with respect to u, whatever that you're going to be left with. Remember, the purpose of letting is that these two will cancel. If they are not canceling, then somehow you have made a mistake somehow. That is your substitution method, all right? So that will be minus 1 over pi. We integrate u with respect to u. That will be u to the exponent of 6. We have to add 1. So you have u to the exponent of 6 over the new exponent, and our new exponent is a 6. All right, plus here we now have 1 over pi. So it's 1 over pi into, we integrate, we add 1 here. So it will be u to the exponent of 8 over the new integral, which is 8 plus the constant of integration. And remembering that always where we see this u, we are supposed to substitute with the equivalent u that we had, and our u is what? It's cos pi. So if we multiply this one, we're going to multiply negative 1 times u, which is going to be negative. So it's going to be negative u to the exponent of 6, which is cos. So that's cos to the exponent of c pi x. Multiply the numerators together, pi and 6. This will be 6 pi. So you can just leave it like that. All right. The same thing. 1 times u to the exponent of 8 is u to the exponent of 8. But u is what? It's cos. So this will be plus a cos to the exponent of 8 of pi x, just like the previous case here. then pi and 8 multiplies, so it will be 8 pi plus the constant of integration like that. So that is the idea. That is the whole idea of our question. We are done. So we just have to be careful on your simplification, how you simplify each stage by stage up to the final part. All right, then we move on to the other part, which is, all right, let's check, that is 2.5. So on 2.5, we are now asked to integrate again with respect to x, and this is sine squared. One mark, guys, there's no need for us to use any substitution method or any trick there. Use the formula sheet, all right? The formula sheet, it is, let me show you this formula. This is there, straightforward for a sine squared. The sine squared, there's no need for us to struggle that much, guys. Where is it? I think it's this page, all right? There's a sine squared there, here. All right, it's the other page on top. On top is what cot. So it's at the end here. So I'm just gonna work it on this page. I'm just gonna simplify on this page, this question. I'm just gonna, or maybe I did not insert it. No, I inserted here, exactly here. All right, I remember that I inserted this one here. They gave you this integral, so you just have to apply the formula. Check the last one, this one. These are integrals here, all right? F of x, the f of x here, then this is the integral. So our question there, I'm just gonna answer this question on this page here. There's no need for me to rewrite there. All right, just one mark there. So it was 2.5. It was the integral of, all right, sorry, let me just reduce here. So it was given as the integral of, that was sine squared. So this is sine squared 3x over 5. So it was sine squared like this with respect to x. So if we check, this is the same format, sine squared ax. So as long as we can properly see our a to say the a is the number that is affecting x, we are supposed to get our answer as x over 2. This is our question. So our answer is supposed to be x over 2 minus sine in this case, which is sine of what? Of 2ax. So it's 2 times ax. Our ax is the part that is affecting this is part of x, which is 3 over 5x. So it's going to be 3 over 5x like this. Everything over what? 4a, which is 4 times our a, which is a is the number that is affecting x, this one, which is 3 over what? 3 over 5. So it's going to be 4 times 3 over 5 like this. This is what they are simply trying to say from this formula, then plus the constant of what? Of integration. So that's it. We can simplify this part. So this will be x over 2 minus. So here we can simplify this the same as we've got 1 divided to this one here. So I'm just going to show you on the calculator what I'm trying to say. This is what you do. On your calculator, just divide straightforward, just once here. 1 over, like this, 1 over this. So it's 1 over 4 into the bracket of 3 over 5, into the bracket of 3 over 5, like this. This is going to give you 5 over 12, all right? So here we are going to get 5 over 12, all right? Sorry for that. So that will be 5 over 12 from the simplification of this. But there is a sign, so it's sine 2 of this. So you can leave it like this with these 2, or you can multiply 2 multiplies the numerator. 2 times 5 over 3 over 5 is going to be 6 over 5. So you can even use your calculator. 2 times 3 over 5, multiply inside 2 times 3 over 5, which is 6 over 5. So this will be 6 over 5x. And this is a single term like this, plus the constant of integration. So that is how you integrate a sign. You have the identity, you have the integral, the formula, the integral that is directly or specifically for that sign. It's a sine squared. It's not like sine to the power of 4 or something sine to the power of. Yes, we could have used the identity. And I talked about that on the introduction of these identities. So just make sure that you watch those introductions of these, of these integrals of the trigonometric functions. I explained how to integrate the same sine squared using the original method or the traditional method that we are used to instead of using the formula. So we just hope for more questions, but that was the whole part of our question number 1. Just expect to have more of this in our time.